Okay, so today we are going to discuss some NT test questions which are related to the topic sets. So let's get started. All right. So here's the first question. Which one is not a set? Okay. So the first question says, which one of the following, like we have four options, is not a set? Before thinking about it, let's just write down the definition of sets. Okay, so if we define set, we can write set is basically a collection of well-defined distinct objects. Okay. All right, so this is how we define a set. In a set, we have a collection of well-defined, distinct objects, right? Now the question says which one is not a set, right? So in C, we can see that we have four two times. However, we want distinct objects, distinct elements in every set. So all the options other than C have distinct objects. Like in A, we have 1, 2, 3. In B, we have 3, 4, 7. In D, we have 9, 7. Every number is different from the other. But in C, we have two same numbers, that is 4, which means that it is not satisfying the definition of a set, which basically should have distinct objects. So this means that C is the answer because we were supposed to find not. All right. So the second question is this one. Okay. So the question is an element B of a set B can be written as. Okay. Now the element is small b and the set is capital B, right? So here we are discussing the notation, right? So I can write it as that small b belongs to the set B. Obviously, I can rewrite this thing this way, right? And if I define it in mathematics, it would be written as B belongs to capital B. So this is the sign which we use for belongs to. This means that C is the answer. All right. So this was easy. Let's talk about the third question now. All right. Now they're saying the union of all even integers and odd integers is. Okay. Now, first, let's talk about even integers and odd integers. If I write down the set of even integers, I am going to add all the negative even integers. Then I'm going to add 0. And then I'm going to add all the positive even integers, right? So I will have 1, 2, 3, these types of numbers. And if I talk about odd integers, so in this case, I am going to have negative odd integers and I am going to have positive odd integers. So if I simply think of all these numbers together, so it is going to be -6, -5, -4, so on to 0. Then we are going to have 1, 2, 3, 4, and so on, right? So we have 0, we have all the positive odd numbers, we have all the positive even numbers, we have negative even numbers, negative odd numbers. So this whole set of numbers is basically the set of integers, right? So we are going to have A as our answer. Okay. All right, now let's talk about the fourth question. So in the fourth question, we have for any subset B of X. Now X is the big set and B is the small set. B union B is going to be okay. Now let's talk about union here. Right. So whenever we define union, we basically write down the elements of B and let's say if I had A union B. In this case, I am going to define this set as elements of A plus elements of B. But if we have any elements in common in A and B, I would write those elements once only, right? Let's say if I consider this A union B as my example, in this case, in this set, I am going to write down the elements of A plus B. But the elements which are coming in common would be written once only. So if I have some elements in A and B both, I am just going to write them down once only and not twice, okay? Because if I'm writing those elements twice, this would not be a set, because if I write something again, just like the very first question where I discussed the definition of sets, we can only have distinct objects, right? So we define union this way. I write the elements of A, I write the elements of B, and if any elements are coming in common, I just write them once, okay? So here if I talk about B union B, now B and B, both these are same. So this means that every element in both of these sets would be a common element, right? So this is basically going to be B. But if I look at the options, I do not have any B, right? So now I need to think about it. Okay. So definitely it is not going to be null set, like A cannot be the answer. Okay. And if I talk about B, that is X, this cannot be the answer because B is a subset of X, right? So B union B only has B. It has nothing to do with X. So this cannot be the answer. If I talk about this B union X, B union X would basically be X, because like X is the bigger set, B is the smaller set. X already has B in it. So as I said, when I talk about union, I write elements of B, I write elements of X, and the elements which are coming in common, I write them only once. So this B is basically in this X, right? So I will write down X only, that X is going to have B as well. Okay, so these three cannot be the options. So definitely we're left with D. So D is the answer. But why is D the answer? Okay, now let's talk about B intersection B. Now let's say if this is the set B, and I'm talking about the intersection of it with B, right? Here's the set B, which I have drawn with blue color. And now if I talk about its intersection with itself, with the set B, obviously I am going to get the whole set back, okay? I am going to get this whole yellow thing. So this is basically B, right? This is basically B. So I knew that B union B is B and B intersection B is also B. So this means that D would be the answer. Okay, we are done with this as well. Now let's talk about the fifth question. Okay, now the fifth question says A union A complement. Okay, A complement, right? So basically A complement is going to have the elements of the universal set excluding A, right? And here, if I look at my options, I can see that X is basically the other set. So here, X is considered as the universal set, right? So if I write this down again, A union A complement, where I know that A complement can be defined as universal set minus A. So I can write down universal set as X, because when I'm looking at the options, the only variable, the only alphabet other than A is X. So that means that here they are considering X as the universal set minus A, right? So I can use this over here. So A union X minus A is basically going to be the answer, which is D, right? So just know that whenever you have A complement, B complement, or complement of any set, that is basically going to be the universal set minus that set whose complement you are finding, right? You were finding A complement, so you are going to write universal set minus A. All right, so we're done with the fifth question as well. Let's talk about the sixth question now. Okay, now we have A dash X. All right, now think of it as A minus X, right? Okay, so this is basically the notation which they have asked, but you can always think of this dash as minus, right? Now we know that A is a set and X is the big set, X is the universal set, right? If I am subtracting the universal set from the small set, obviously I'm going to get nothing, because like I have a big set and then I have a small set, right? This small set is A and this big set is X, and obviously this X has A as well, okay? So maybe I should draw it this way just so things are more clear. Right, because X is the universal set and A is the small set. And now when I'm subtracting, when I'm doing A minus X, I am going to get the null set. Because when I'm subtracting X from A, obviously A would be finished, right? We would not have any element in A because A is the small set and X has every element of A. So when I'm subtracting it with X, I would get the null set, right? Okay. Now students might think that A, this option could also have been the answer, but you have to be clear, okay? This would have been the answer if we had X minus A. In the fifth question, we have just discussed this part. This is how we define A complement, right? So this would have been the answer if we had X minus A. But since we had A minus X, so this C is the answer, because like A is the small set, X is the big set. X already has every element of A. When I'm subtracting it from A, I would get rid of every element which I have in A. So it would end up as a null set. That is basically an empty set. Okay, so this is basically empty. This basically means that we are going to get an empty set. Okay, with no elements. All right. Now let's talk about the seventh question. Okay, now here we have A minus B union B. All right. Okay, so A and B are two sets, and I am basically saying that I am going to subtract, I am going to take out the contents of B that are in A from A, right? So this is what A minus B means. That let's say I have a set A. From that set A, I am going to take out all the elements of B, and then I am going to take its union with B, which basically means D. Why? Okay, I'll tell you. Now in A minus B, I only have elements of A minus elements of B which we had in A. Okay, so I can write A minus B as this, that A minus B would have elements of A minus elements of B which we had in A, right? and then I'm taking its union with B, which is basically going to give me all the elements of B back, right? So this is why D is the answer, and this basically is a property. So whenever you have A minus B union B, this is always going to be A union B because this is a property, right? So obviously, behind every property, there's a logic, and this is the logic. Although we have taken out the elements of B from A in this part, but then since we are taking the union with B, we are basically going to get back all those elements and all of that A as well, because like this basically already has every element of A other than the elements of A which were in B as well, right? But since we have taken its union with B, so we are going to get back all the elements of B which were in A as well. So in short, we will get the whole A back, right? So since after A minus B, we had union B, and A minus B implies every element of A without the elements of A which were in B, means that we only are going to consider the elements of A without the elements of B which were in common with A. And since we are taking union with B, this part, we are going to get back this part. So once we have this part back, obviously that would make up all of the A with B. So D is the answer. So if you're not able to understand it this way, just think of it as a property and learn it, okay? Because like we do have properties, we do have theorems, corollaries in mathematics. So just learn it as a property. Whenever you have A minus B, union B, this is going to be the answer, okay? So D is the answer. All right, now let's talk about eighth question. So here the universal set is defined as 1, 2, 3 till 10. Okay. Now we have like 10 elements in this set, and A has 1 to 5 and B has 6, 7 only. Then A intersection B complement. Okay, so what is A? A is 1, 2, 5. A intersection, all right, with B complement. So intersection with B complement. Now B is basically 6, 7. So B complement is going to have the universal set without these elements of B. So I will have 1, 2, 3, 4, 5. I will not have 6. I will not have 7. I'll have 8. Then I'm going to have 9 and 10. And now if I take the intersection, I only have 1, 2, and 5, right? I am only going to have 1, 2, and 5, which basically is A. So C is the answer. Now here clearly one thing was very obvious. Since we are taking A intersection B complement, the only thing which we had to make sure was that B complement should have the elements of A. Like if B complement has every element of A, then definitely their intersection would be A, because like A is the small set, B complement is the universal set without the elements of B. So this was certain that B dash would be the bigger set and A would be the smaller set. Now, as soon as we get to know that B dash has the elements of A, like 1, 2, and 5, we can say that the intersection would be A. So C is the answer. Okay, we are done with this. Now let's talk about the ninth question. So we have A equals 1, 2, 3 and B is C, D, F. So we have been asked to find A intersection B. Now obviously in intersection, we look for the common things, right? Now obviously here we have numbers, here we have alphabets, so nothing is in common, which means that we are going to get the null set. That is the empty set, which means that the set that basically has A intersection B would be empty. So this is how we define it. So C is the answer. All right. Now let's talk about the 10th question. Okay. Now the 10th question says if okay, two sets X and Y are disjoint if okay. Disjoint basically means that X and Y are going to be separate. In other words, they would have nothing in common, right? So this nothing implies that the set which we are going to get as a result of their intersection would be the null set or the empty set. So C is the answer, right? So this is how we define disjoint sets, that the intersection is empty, the intersection is null. So C would be the answer. Okay. Now let's talk about the 11th question. Okay. So the 11th question says if A equals 4, 3, then P of A is. Okay, now first thing is that what is P of A? P of A is basically the power set. It is the power set. And if we define power set, we can write that P of A basically is collection of all proper and improper subsets of a set A, right? Okay. So power set P of A, this set basically has the collection of all proper and improper subsets of the set A. Okay. Now set A basically has 4 and 3, right? And improper subset is basically every set itself. So the improper subset of A would be improper subset would be 4 and 3, and the proper subsets would be 3, then 4, and then we are going to have this null set as well. Okay, so since power set is defined as the collection of all the proper and improper sets, so improper sets are very obvious, like if we have 4 and 3 in a set, we are going to have 3 as the proper subset, 4 as the proper subset, and this null set as the proper subset, right? And for the improper set, we are going to have this set as it is, that is 4, 3. So the collection of 1, 2, 3, and 4 is basically defined as P of A, right? So A is going to be the answer because A set has null set, which is the proper subset of A, and null set is basically a proper subset of every set. Okay, then we have 4. 4 is basically proper subset of A. 3, again 3 is proper subset, and 4, 3, this is the improper. So it is the collection of all the proper subset. We have 3 proper subsets, 5, 4, and 3, and improper subset, that is 4 and 3. So every set has one improper subset only, right? Because improper subset is that set itself, right? So A is the answer. Okay. We are done with the 11th question as well. Now let's talk about the 12th question. Okay, so this is the 12th question. All right. For any set X, Y, and Z, X intersection Y union Z. Okay. Now we basically are going to define this set where we have X intersection with Y union Z. Okay. So here we have X intersection Y union Z. Okay. Now think of three sets. Think of X, Y, and Z as three sets, and just know that we have Y union Z. So Y union Z is going to have all the elements of Y and Z, and those elements which are being repeated in both of these would come once only. Okay. And then we have X intersection Y union Z. So if we all right. So if we think of it as two sets which are being intersected, right? We are going to get this as our answer. Why? Because here we clearly have X intersection Y union Z, right? So whatever elements which are common in X and Y, and then their union with the elements which are in common in X and Z would basically be this. Okay, so we are going to have X intersection Y, then we have this union sign here, and then we have X intersection Z. Okay, so this is how we can rewrite this set as this. Okay, it is mathematically correct. So since we can rewrite this set like this basically is going to come here, and this intersection side would come here and come here, right? So B is going to be the answer. Okay, so we know this mathematically. We know this, that since we can define it this way, like this set can be defined this way, so obviously B is the answer. But now if we think of it logically, we should know that if we have three sets, X, Y, and Z, where X intersection Y union Z is basically the new set. Now, obviously, Y union Z is going to have all the elements of Y, all the elements of Z, and the elements which are coming in common in Y and Z would be written once only, right? And now when we take the intersection with X, we are basically going to get the elements which are common in X and Y, and the elements which are common in X and Z, right? So if I add both these sets, if I find the union of both these sets, I am going to get the B option, right? So this is why B is the answer. Okay. Now we have 13th question. Okay. So here basically we have for any two sets, X and Y, X union X intersection Y is going to be. Okay, all right. Now, if I talk about this part, X union X intersection Y. Okay. Now, X intersection Y is going to have the elements of X basically which are in Y as well, right? So this is going to have all the elements of X and Y which are common. So in short, this set is basically a part of X. Okay, this set is basically going to be a part of set X, because X intersection Y implies the elements which are common in X and Y. So basically it would be a part of X. And now when I'm taking X union X intersection Y, where X intersection Y is basically a part of X, I know that it is going to have the elements of X and the elements of this set, and the elements which are common would be written once. Okay, so obviously this whole set already belongs to X. This whole set already belongs to X, and since I have to write the common elements once only, I am going to get X union X intersection Y. So I am going to get X only because I do not write the repeated elements. I know that the common elements would be written once only, and this set X intersection Y is already in X because X intersection Y has the elements of X which are in Y as well, right? So we are going to get A as our answer. Okay. And now let's talk about the last question. It is the 14th question. Okay. So we have, if A and B are any two sets, then which of the following is always true? Now we only know that A and B are two sets. That's it. Okay. So let's see A. A says A union B is subset of A intersection B. Now we know that A union B can be a bigger set than this, right? Because obviously A union B would have the elements of A plus the elements of B. And if we have any elements in common, we will write them once only. And in this set, on the right hand side, in this one, we only have the common elements. So clearly, this cannot be the subset. A intersection B can be the subset of A union B, but we cannot have A union B as the subset of A intersection B because this is the big set and this is the small set, right? So B is the answer because like if A and B are two sets, we do not know any other thing about these sets, but if you look at B option, we can see that the elements which are common in A and B would definitely be the subset of A union B because they are going to be in A union B, right? So B is the answer.